to you in this form. I'm going to tell you this. You're going to listen to me. You're going to go to the test, and you're not going to be able to answer these because you're not going to have listened to me, and you're going to try and fill it into this equation every single year. What is this? 14 seconds in, March 15. I'm looking this up when the test comes along and you don't answer these, and I'm going to be like, I see, recorded. So, every time I ask you to determine the equation of a polynomial, don't even look for what equation form I want, because there is only one that you can find the equation for. I don't know why I'm doing fish movements. Yeah. Anyways, yeah. See? There's only one equation. Can you fill it into here, Ty Archer? Can you?
I'm not into that point.
Ty Archer failed me. Failed me. No, you can't. You can't fill it into that form. You must fill it into the factor form. Yeah, that's what I thought. My nephews are always like, Auntie, you don't call people out when they're on their phones and stuff. I'm like, actually, that's exactly when I hit them. I hit them right when they're on their phones. And then I'm like, what do you think? And they're like, you don't do that. You don't call out in front of the whole class, do you? I'm like, yes, I do. It's where I roll. This is what a good teacher does. You train them, and they will never pick that phone up for at least 2 days. If they're in some classes, at least 10 minutes. But it slows them down. All right. You're never on yours. That was kind of comical that I hit you right at that 1 second. I think it might be the first time. Cool, but I got you. All right. So, y equals, and you know the answer. He knows you can't put it into that. All right, so we're going to go a x plus 3. Now, why is it x plus 3? You can use transformations, or you can say, hey, the root was x minus 3. Yes? The factor, I have to get it equal to 0, right? So I add the 3 back over, and I get x plus 3 equals 0. Okay? So you're working backwards. So what if my x-intercept was a half? Some people tell me x minus a half. Not an incorrect statement. We'll never be there, so you aren't going to get an answer to match it, because they're going to ask for an integer one. And was x equals a half? Was it x minus a half equals 0? Was that the factor you got that got you to a half? No. What do you have to do, Ty? You're right. You're showing hand signals.
You have to multiply the denominator across.
Yes. You have to multiply the denominator up. So we get 2x equals 1. And then we have to? Yeah, minus the 1. So you have to remember there are numerous steps. Now some people will say, well, where is there x equals a half in here? There's not. I just wanted to prove that if it's not a whole number, because I picked all the ones that are whole numbers, that you can work it back still. Okay? It's nothing to do with this question. Then I have x minus 2. Now, where does the problem happen in these questions? You forget to put squareds on the tangents, and you forget to put cubes on the inflections, right? Multiplicity 3s, multiplicity 2s. So this one is a multiplicity 2, so I have to square the factor, and then I have x minus 5, and then I have the coordinate 0 and negative 2, which is my x and my y. So now I have this. Negative 2 equals a, 0 plus 3, 0 minus 2 squared, 0 minus 5. And I get negative 2 equals a times 3 times 4 times negative 5. Negative 2 equals what? Negative 60? Divide by negative 60, a, and a equals 1 over 30. So that can't go into that equation. It has to go back into the one I came up with, and I only ever do factored form. Yes? Okay. So I get y equals 1 over 30, x plus 3, x minus 2 squared, x minus 5. Now, this is where I need you to bring all your brain cells. Every brain cell you got, we're bringing it in. Okay? If they ask me to find b, c, or d in that equation, you see that? The b is in front of the x cubed, the c is in front of the x squared, the d is in front of the x. If they ask for any of those, which I've I think I've seen once. If they ask for any of those three, you have to expand the whole thing. There's no other better way. Okay, you have to expand it, the whole thing. But what do they normally ask for? They normally ask for the A and the constant at the back. Those you do not have to expand the whole thing. Okay? How do we get the A? Well, if they ask us for the A, which they'll ask us for A and D, they don't often ask for that form. What we do is we just write 1 over 30, and I'm going to show you how I do it so I don't mess up. 1x plus 3, 1x minus 2, and then I write this out twice. 1x minus 2, and 1x minus 5. So to get the A, I need to multiply my leading coefficient, or my vertical stretch, that A value I just found, by all the x's. Right? So if I take this, because I need what gets me x4, right? So if I go 1 over 30 times 1x times 1x times 1x times 1x, I get 130 times x times x times x times x, which is 130 x to the 4. What's in front of the x to the 4? My A, right? So in this equation format, in the format y equals ax4 plus b x cubed plus cx plus d plus e, A is 1 over 30. When does A not stay what A is? When we expand it. What would have to happen in order for A to change to something else? Here I have a 1x, a 1x, a 1x, a 1x. So A stays 1 over 30. What would I have to change in order for that to happen? Now I have a 1. I have something else. Like perhaps a 2x minus 1, right? Then I would have to go 1x times 1x times 1x times 2x, and it would double my A, right? It would double it. So if all of your factors or x-intercepts are whole numbers, like x equals 2 and x equals 5 and x equals 7 and x equals -4 and x equals -1, if all of your x's are whole numbers, cool. Your A will be A. Your A that you find for the factor form will be the A that you find for the standard form, for the one that's all expanded, okay? If, however, you have an x-intercept that is a fraction, like a third or a half or something like that, you're going to end up doubling or tripling your A because your leading number in front of your x will be a 2 or a 3. Okay? Does that make sense? All right. Now, the other thing they ask for is E. What is our E? Our y-intercept, right? So our y-intercept, if we use this form, our E is our y-intercept. If I'm looking for my y-intercept, I could set x equal to 0 and solve, correct? So I could get y equals 1 over 30, 0 plus 3, 0 minus 2, 0 minus 2, times 0 minus 5, and I get -2. How the heck did I figure that out without doing any math in my head? Yeah. The point I bolded is the y-intercept. It's 0, -2. I didn't actually have to calculate it at all. It was given on the graph. So sometimes to find that E, that last letter that they ask for all the time, like you see on your hand-in, I've asked for A and D on one of them. D is the y-intercept. A is just expand them all out. Do you have to expand 5 factors in order to get A in the last term? Nope. A, you just multiply all the leading x's with that A you found. The constant is your y-intercept. You either plug x in equal to 0, or if the graph actually gave you the y-intercept, sweet, you have the last letter. Does that make sense? All right. So part of your homework for tonight is going to be to find the A and the constant for all of them without actually expanding it. Okay, for the last three. We're going to go over those tomorrow. Now, what I want you to do in the meantime is take out a separate piece of paper because we're going to go through a volume question like I told you we would do. All right. So in your hand it's 20 and 10. For today, I'm going to use 18 and 8. So I'm going to say the length is 18 and I'm going to say the width is 8. Now what is this? So this is like these little boxes here, guys. Where are they? These don't actually exist. Those don't exist. What does that mean? Pick this up later. Ooh, got a little rippy copy. So, pretend those are perfectly not ripped there. Oh. Okay, so what you actually have in front of you on your little piece of paper is you have this, right? You're almost like a sideways cross. That's what you have. So when they drew it as like a dashed line, and then they show it to you as a 3D figure beside it, and they show it to you as like a box where you took these side lengths and folded them. So in your hand you have that like 3D box shape beside to show you what they did. So they took these and then they just folded them all up. So great. And they got themselves a box. And like that, right? And the height of the box is X, because they told you that this length that they ripped out, this here is an X, right? They labeled this as an X here, and they folded it up. My height of the box is X. But now I need to get the length and the width, right? And they told us that this is X, and 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 this is X. And they told us that this whole thing was 20. I'm going to say 18. And they said this whole thing was 10, and I'm going to say 8. So the whole thing is 8, right? And the whole thing is 18. But I want just the width of this. Make it yellow. I want this. Because that's the only part that flipped up. These here, these little boxes on the side, don't actually exist. I could even do this. Right? And then this box folds up and makes box, right? So this length here is X. This length here is X. This whole length is 8. So what is this length? What would it be? Yeah.
8 minus 2.
8 minus 2x. 8 minus x and 8 minus x, so 8 minus 2x. Totally. So that's going to be my width. If this is 18 across the whole bottom, and this is x, and this is x, and I just want this piece here, it's going to be 18 minus 2x. And then these, when I fold this up, and I showed it to you because they have a 3D figure just on the side, right? This is x, because I take this piece here and I fold it up. So here's the length of x, right? So my height is x. So my volume formula is length times width times height. So it's going to be 18 minus 2x times 8 minus 2x times x. Mine. Do not give this as your answer on the hand-in, because your numbers are 20 and 10, and mine are 18 and 8. Okay? Not going to be the same numbers. Okay, so A asks to determine the expression that represents the volume of the box. Cool, done. except yours is going to have a 20 and a 10. I believe in you. Okay, then it wants us to sketch the graph with and state the restriction on the domain. So everyone type that into your y equals. Some people go all like FOIL happy. You don't need to FOIL this. It just wants an expression, right? It didn't say the expression can't have brackets. It didn't say it has to be in standard form. So you type it in with the brackets. Oh my gosh. And then press graph. This is a cubic function. Why is it a cubic? There's an x in one bracket, an x in another bracket, an x in another bracket. X times x is x cubed. So I know there's like an S shape on here, right? So it's coming down, then back up, and then back down. Anyways, I'm going to change my y max. I tried 40, it's not high enough. I'm going to try y max at 100. Oh, getting closer to the maximum. I'm going to try it at 120. So, when you go to sketch this graph, I see a whole bunch of people doing this. Okay? True, that's what's on your calculator. I don't deny that. But remember, your x is height. Do you see this? Height, x, height, x. Can height ever be zero or be negative? No. So, see ya later. Ella, later. She gone. Okay, what's my y? Look at my equation. What's my y? Volume, right? There's volume here. It's v. Can I have negative volume? Can I have zero volume technically? If I have zero volume, do I have a box? No. So I halt at zero. Like that doesn't. But I'm going to leave the excess. So, oops. I take my eraser, and this is gone. I could leave the y-axis, I guess. This is gone. Once I'm done, once I've hit negative volume, it can't come back again. So this is gone. This is gone because that's negative volume. I've hit negative volume, so is this. This is gone too. Bye-bye. See you later. The only thing you should have drawn was that first bump. Okay? So everyone needs to find our first x-intercept. How do we find x-intercepts? Second, trace, 0, which is number 2, the word 0. Now it says left bound. So I need to be somewhere on the left bound of it. So somewhere up here. Enter. Because if I drew like a little straight line through it, that's the left. Then I need to be somewhere on the right bound. So down here. Enter. And then it says yes, I just hit enter. What's my x-intercept at? What's this one at? 4, right? You need to be able to use your calculator. So this is at 4. This is 0. So what's my domain? Think of x as height, correct? X such that 0, 4, x, then I told you less than equal to signs on both, or less than signs on both. Do I do equal to's? Can my height be 0 and my height be 4? Would that help me get a volume of a box if I have no height? It's actually not even it's not a box, it's a piece of paper. Paper has height. It's the table. I don't know. Like you literally can't have a box if you don't have a height, right? Even a piece of paper has a very thin height, right? So don't put equal to signs. XCR. If you do it in interval notation, it'd be 0 to 4, round brackets. Now my range is my volume. This time I used v, so I actually can't use y, I have to use v, such that 0 is less than the volume is less than, I need to get my highest volume, VER. How do I get my highest volume? Find the what? The maximum. How do I find a maximum? I go second, trace, maximum. It says left bound, so I need to be on the left side of that maximum, enter. Then it says right bound, I need to be on the right side of that maximum, enter, enter. And I actually get a maximum at 2 and 114. That's where my maximum's at. So my largest y is 114. Something buzzing, or am I losing my mind? I feel like I might be losing my mind. Sometimes I randomly have weird alarms on at like 9, 11, 15. So sometimes it worries me, but it's not. Okay. I feel like my kids are punking me and putting random alarms on my phone. Either that or I'm really old and I just forget I put random alarms on the phone. Okay, C says determine the value of x. The value of x to the nearest hundredth of a centimeter that gives the maximum volume. The value of x that gives the maximum volume. What's my x that gives me a maximum volume? 2. So this would be 2 centimeters. It says nearest hundredth. Cool. 2.00 centimeters would be this one. Then D says, what is the maximum volume of the box to the nearest cubic centimeter? What's the maximum volume of this? What'd you get? Is it the 2 or the 114? 114, because volume is x or y? Y, right? So it would be 114 centimeters cubed. Does that make a little more sense how you deal with the question? Except you have 20 and 10. Please don't give me these answers. I will look at you silly, like you're silly. I'm going to get you to open your notes up to where we left off. So, yes, you can. All right. So, this one says, sketch the following rotational angles and give their reference angle and give 2 coterminal angles. Well, we know how to sketch and we know how to do coterminals, so we'll do those first. So, I have to label 0, 90, 180, 270, 360 degrees. Where does 60 fall? In quadrant what? Quadrant 1. Remember, the quadrants go in like the letters C, like Crystal, because that's my name, or calculus, which is more mathy. But this is much better because it's me. Crystal, look at that. This is quadrant 1, this is quadrant 2, this is quadrant 3, this is quadrant 4. Or you could do calculus, which is like math, but super boring. All right. So it's in quadrant 1. We have to have an initial arm. We have to rotate about 0, 0, like we have our little arrow on our unit circle. And this is 60. Now remember, I told you that you can use your little rotating unit circles. This will help you much more even on the next lesson that we do, which is on the unit circle. So if I take 60 and I rotate it clockwise, counterclockwise 360, I'm going to end up with 360 plus 60. True? If I go the other way, I'm going to have 60 minus 360 because I'm going the other direction. Right? So if I want 2 coterminals, I just do 360 degrees, 60 plus 360 degrees, which gets me 420 degrees. Or I could go 60 minus 360 degrees. Make sure you have degree symbols or it's not a degree. And I get negative 300 degrees. Now negative 300 would land on the same spot because if we're looking at our x-axis and I have to go negative 300 degrees, watch me. I go negative 90, gets me to the bottom axis. I go negative 180. I go negative 270. Then I need to get negative 300. Whew, did it land back on my 60? Yeah, so you can test it by rotating it. It should land back on the 60. Now, are those the only two coterminals that exist in the world? No, I could keep subtracting 360 for life and get more. I could keep adding 360. So when it's a multiple choice question on a test, they give you one that works. And it could be in the first by adding 360, it could be adding 360 twice, but you have to test them out and find out your coterminals, right? So it's multiple choice. Some people say, what if they gave two of them? That would be stupid, because then you'd have two correct answers. Like, they're not going to do that. They're going to give you one, right? Okay, so everyone's pretty good with coterminals. Everyone's pretty good with drawing, okay? Your reference angle, just so you know, is your little acute angle between the terminal arm and the x-axis. I'm going to write that here. Reference angle. I call them bow tie angles. They're the angle between the terminal arm and the x-axis. They're always positive. So even if you're doing a negative angle, your reference angle will always be positive. So it's the angle between the terminal arm and the x-axis. So for 60, what's the reference angle? 60. Quadrant 1's the best ever because its reference angle is the same as its angle, right? So quadrant 1, the reference angle is the same as the angle. So this one has a reference angle from here back to the x-axis. And why do I call it bow tie angles? Because it's this angle in quadrant 1, it's this angle in quadrant 4, this angle quadrant 2, this angle quadrant 3. So if your terminal arm's here, it's this angle. Terminal arm's here, it's this angle. So it's the bow tie angles. It's the angles that fall between the terminal arm and the x-axis. You're making hourglasses, you're doing it the wrong way. Some people say, well, what's the angle between the y-axis? It doesn't. It's not. No curriculum. Nowhere ever will they ask you that. So do not find that. Okay? So this one, the reference angle equals 60 degrees. Now, if your question is given in degrees, your answer has to be given in degrees. If your question is given in radians, your answer has to be given in radians. Some people suck at drawing radians. Could I convert it to a degree and draw it? Sure. Also, anything over 3 has a 60-degree reference angle because pi over 3 is 60. But anyways, 5 pi over 3, how would I convert it if I wanted to draw it? How do I convert from radians to degrees? Do I multiply by 180 over pi or pi over 180? Yeah.
180 over 2.
Why?
So that cancels out.
Yeah, to cancel the pi, but also I need a
Degree.
degree symbol, correct? If I have 180 in the bottom, I'm going to have a degree symbol in my denominator. That's not helpful. I need a degree symbol in my numerator. So I'm going to divide times by 180 degrees, so I end up with a degree symbol over pi. These cancel. And I get 300, I believe. So I can draw the question in degrees, but I have to label it in radians. All my answers have to be in radians. You can't just be like, I like degrees better. I'm going to give all my answers in degrees. You can't. Well, you can. You just won't get any marks. So I have 0. Then I need to label these in radians. Pi over 2, pi 3 pi over 2, 2 pi. Now I know it's where 300 degrees is. So I have my rotating arm 0, 0. My initial is at 0. 300 is here. I have to show my arm rotating counterclockwise because it's positive. And I put 5 pi over 3. There are two things that radian measure are good selling features. There's two. I have to come up with something because most people hate them. One, word problems only work in radians. Two, the reference angle is really easy. There's no thought process on the reference angle. If this is 5 pi over 3, my reference angle is pi over 3. If it was 8 pi over 11, my reference angle would be pi over 11. If it's 9 pi over 2, my reference angle is pi over 2. It's the greatest thing ever. There's your one selling feature for reference angles. So this one is 5 pi over 3. So my reference angle will be pi over 3. There's your one reason why radians are off. Live in that area for a few seconds. Now, some people will go 300 plus 360, 300 minus 360, then convert to radians. Don't. Coterminals are easy to do with just using 2 pi's and subtracting 2 pi's. Okay? So, for my coterminals, I take my principal angle, or my angle that's given to me, and I say theta equals 5 pi over 3, and then instead of adding 360, because it's not degrees, I'm going to add 2 pi. How can I put that in my calculator so I don't run into a problem? Don't put in the pi's. Just add the pi back after, right? If I put the pi in, I can't, math enter will never work. So, if you use alpha y equals enter, you could just do 5 over 3 plus 2. If you don't use alpha y equals enter, you have to put the 5/3 in brackets. What's 5/3 plus 2? Everyone should type it in because I can type it in or I can just do it in my head because I get a common denominator. It's 11 pi over 3. So you should be getting 11 over 3, correct? Then I just take my 5 pi over 3, and instead I subtract 2 pi. What am I doing? I'm making a common denominator. So you can use your calculator, or you can say, hey, 5 pi over 3 minus 6 pi over 3, except the common denominator is negative pi over 3. You can actually do the math for it. Or you can go 5 over 3 minus 2 without the pi, math enter, and I get 1/3. Negative 1/3, right? So I'm going to get negative pi over 3. Okay. Yeah. This one I want to draw negative 2 pi over 3. First off, I just go look at my unit circle and see if 2 pi over 3 is on it. Is 2 pi over 3 on your unit circle? Yes, it is. What is it equal to? $120, right? So this is actually the same as negative 120. So if I want to sketch it, remember I have to not only go clockwise, I have to label in radians. So this is going to be 0. This is going to be negative pi over 2. This is going to be negative pi, negative 3 pi over 2, negative 2 pi. You have to label in radians even if you're using degrees to draw it. Okay? Rotate here. This is my initial. My terminal is going to be at negative 120, so I'm going to go here, 30 more. Arrow it, label it properly, negative 2 pi over 3. What's my reference angle? Remember, these are easy. Reference angles can be negative. Pi over 3. That's it. Because of this. They're the easiest. I'm telling you. Go to do our coterminals. I'm going to go negative 2 pi over 3 plus 2 pi. So you go negative 2/3 plus 2. And you get, what did you get? 4 over. Everyone type it in, because you are not, and you're gonna, and then you're gonna go to the homework, and then it's gonna be awful. Because you're banking on no one typing it in, like not one human. There's now maybe a quarter of the class. Take it, live in it. Pi over the denominator. Yep. Very similar.
Just take it just because.
Yep. Because really, if you look at it in a degree instead of a radian, I'm at 120, right? How far is it from 120 to this x-axis? 60. What's 60 in radians? Pi over 3. And I didn't have to do any work because it's radians. So you live in the radian zone. There's very few positives. There's really one positive. That's it. Live in it. It's just pi over the denominator for reference angles. Other than that, I don't have a great selling feature for radians. I could try and sell them, but don't buy them. But reference angles, because in degrees, you'd actually have to calculate it every single time. Yeah. So it's going to be 4 pi over 3. And then this one, I'm going to do negative 2 pi over 3 minus 2 pi. And I get negative 8 pi over 3. You guys quickly do E and F.
She really is.
I don't believe it. All right. So here, this was in degrees. We have to label it in degrees. It's negative, so we have to label it in negative degrees because we're going clockwise. Okay. Shh. Quiet, please. Negative 135 falls here. Initial. Rotating, 135 falls in the middle. I label it negative 135. How do I get the reference angle? I count from this terminal arm to the x-axis, because that's where the bow tie would be. Yeah? How far is it to get from 135 to 180? 45. People will tell me negative. Once again, reference angles can't be negative. So the reference angle is 45 degrees. I'm not going to do the coterminals. Oh, I'm just going to give them to you because you can add 360 and subtract 360, right? So if I add 360 to it, I can keep adding and adding and adding. I would get 225 could be a coterminal, or I could subtract 360 and I get negative 495, or I could subtract 360 again. Stop it. 4. Why did it just go off the pen? Like, why does it hate me? I don't even know. 750. If you went to draw 750. You would go 360 plus how much more? How do we do it? Go 750 minus 360, and what do we get? Oh, 390. Oh my goodness, still too big. What do we do? Minus 360 again, and what do we get? 30. So what did that tell me? Because I had to subtract 360 twice. Rotate, rotate, go to 30, right? So I rotate once, I rotate twice, and then I go to 30, and I draw my little arm, and then I write it at 750. What's my reference angle for this one? 30. Little bow tie. I'm like, where's my bow tie go? Oh, my bow tie's here. What is that going to be? Oh, that's 30. Cool. And then people are like, but what's my coterminals, Mrs. Lepp? Oh, 390 and 30. You just found them. You're welcome. I just curtsied, in case you were wondering. That was funny. No one laughed. It's fine. Often curtsy. But when I curtsy well, right? My mom made me do oratory, which is like when you have to like do speeches in front of people. And we always did curtsy. It's the thing I was the worst at, the curtsy, the practice. I could oratory like you wouldn't believe. Oratory is a verb. It's an action word. Oratory. Okay, your homework for this is literally just adding the radians to the same questions we did yesterday. So it's page 175, numbers 7 BD. C, D, E, F. I am not really putting you out here, so if you could please do the homework, that would be great. It could be a lot worse. Okay? That's not. Please come with those graphs done, the other 3 graphs, and tell me what the A value would be and what the y-intercept or the constant would be of each one, right? A value and constant for all 3 of those graphs. Just so that they're prepared for tomorrow. So we're going to go through them right at the beginning of class. Yeah, you could do them or not. I'm going to go through them. It's best if someone does them, but I think you've probably done them. No, like the graphs we did at the very beginning that were like this. You're done them, I'm sure. Yeah, just make sure you have the A and the constant done for every single one. That's what we're practicing.